Okay guys, let's take a look at today's lesson. We're going to be looking at factorials and also the ratio test. That sounds so fun. Let's talk about factorials first. Just a reminder about what factorials are. Factorials are actually products and they're indicated by an exclamation mark. So for example, 5 factorial. That's a factorial, right? We've seen that before. We know that depends on which book you look at. It's either 5 times 4 times 3 times 2 times 1 or 1 times 2 times 3 times 4 times 5, whichever way. But it's basically 5 times 4 times 3 times 2 times 1. I mean, that's this is a condensed form of this product. Okay, that's what a factorial is. So in general, in factorial, so we're going to take it to variables now. We're not going to just do 5 factorial, which you actually have that button on your calculator, the factorial button. We're going to take it to variables, to abstract. So in factorial means the product of all whole numbers from 1 to n. That's basically what it means. Whatever in this case, it's 5. So 1 times 2 times 3 times 4 times 5. That's what it means. The value of 0 factorial is 1. This is usually like a surprise to students that 0 factorial is 1, but if it really troubles you that 0 factorial is 1, I'm sure there's a very elegant, beautiful proof online that you can research to see why 0 factorial is 1. It has to do with the empty product, nullary product. That's a number theory. I don't really know a whole lot about number theory, but I just trust that 0 factorial is 1. I just take it at its face value. So that's just what we're going to be needing the background for to be able to do today's lesson. So in calculus, in BC calculus, so this would be a calculus 2 lesson, we actually learned, okay, this is going to be exciting, we learned 10 tests for convergence with series. 10. This is so fantastic. This is one of them. And we're actually going to just do this one test with just factorials. We're just going to work on it with factorials. Could you do this test with other things than factorials? Absolutely. But we are just going to focus on this one test using factorials. So let's talk about the test itself. What this test does is it determines whether a series is convergent or divergent. So we have a series. Okay, this is our series. And we use this. This is what the test looks like. Basically, it's the limit of the a sub n term over the a sub n term. And I'm going to show you what that is. That's basically the next term over the original term. So we work that limit out using the lesson that we did yesterday, limits to infinity. We're just going to expand on that. These are limits to infinity. We work the limit out. If we get a number that's smaller than 1, then this test tells us that the series converges. If we get a number that is greater than 1, then this series tells us that this test tells us that the series diverges. Now, if we actually get a number that is equal to 1, this test fails and you'd have to pick another test. But, I'm not going to give you any like that where the test fails and you have to pick another test, because that we'll save for next year. We're just going to look at ones that work. So we will practice this. Just keep in mind, you don't have to memorize this test. I'm going to write it on the paper for you. You don't have to memorize yet. You will next year. But this year you don't have to memorize what the ratio test is. So just keep in mind that if it's less, the value you get is less than 1, then the series converges. If the value you get is greater than 1, then the series diverges. And of course, if it equals 1, the test fails. We got to pick one of the other 10 tests. So, but we're not doing that this year. Just keep in mind. I'm just going to give you ones that are either would give you a number greater than 1 or less than 1. Okay, not equal to 1. All right, so that's like an overview of what we're going to be working on today. Are there any questions so far? All right, let's get to the examples. So the first examples, what I'm going to do is I'm going to show you the formal way to expand the factorials. We're going to do the formal way first. Do you have to do the formal way? No, you don't. Okay, I'm just going to show you how it is done formally. And then we're going to think about it a little informally. How would we do this if, because the purpose of simplifying factorials is going to be to use the ratio test, to work it. So We're going to just work it out formally first. So what we would do, we're going to expand each of these factorials. And the way we start the expansion, if we're doing it formally, is 1 times 2 times 3, dot, dot, dot. Okay, I'm just showing you how to do it formally. 1 times 2 times 3, dot, dot, dot. And then we're going to expand it. So let's think about this numerically, because this kind of troubles students. If n was 10, this would be like 12 factorial, right? If n was 10, this would be like 12 factorial over 9 factorial. And to expand it, we'd do 1 times 2 times 3 all the way to 12, right? That's what I'm doing, but I'm doing this with variables. Okay, I'm expanding it with variables. So I'm going to, I'm going to choose to start at an n minus 2. And I'll explain why in a second. So I'm going to take this first, so I'm going to take it all the way back to n minus 2. The next one would be n minus 1, then n plus 1, and then n plus 2. Okay, that's fully expanded the top one. Now I'm going to expand, so see what I've done is I've expanded it out so I don't have a factorial anymore. Like the example here, if we did expand it out 5 factorial, it would be 1 times 2 times 3 times 4 times 5. So I don't have any factorials left in the expansion, right? I've basically taken care of everything in this expansion. So in the denominator, I'm going to again do 1 times 2 times 3 dot, dot, dot. And I'm going to take this one back to n minus 2 times n minus 1. Okay, so those two are fully expanded. So once we get them fully expanded, we're going to cross out the factors that match. So of course the 1, 2, 3 always goes away, the n minus 2 and the n minus 1. And what we're left with is the simplification of those two factorials. We're left with n times n plus 1 times n plus 2. That's what we're left with. So I want to pause there for just a minute and make sure you're all caught up with me. So that's how we would do it formally. I would like to think about it informally for a moment. Okay, let's think about it informally instead of expanding it formally, because we're going to be actually needing to simplify. Notice that which one of these factorials is larger. The one with the plus, right? Because if we think about n being, for example, 10, I would have 12 factorial over 9 factorial. We understand why the top one is bigger, right? So the bottom one is embedded in the top one, right? Because if you think about 12 factorial over 9 factorial down is going to go away, right? We're just going to be left with 10 times 11 times 12. So what we know is that the smaller one is embedded inside the bigger one. And we just need to figure out where that stops, or begins, I guess, if you will. So if I were to take this bottom one, it's the smaller one, I'm going to leave it like that. And I'm going to take the top one and I'm going to expand it out, starting with this one so that I can cancel the factorials. So if I start with the n minus 1, I would also have an n, I would also have an n plus 1, and I would also have an n plus 2. And those go away and I'm left with the same thing we got. Okay, so that's another way to think about it. In fact, you don't have to write out any of this at all if you don't want to. If you can see what the simplification is, you can just write down the answer. I'm perfectly fine with that. I mean, you don't have to simplify this in a specific way for me. I just need you to understand how we are simplifying. Okay, questions so far? Yes? You could take it back as far as you want. I just arbitrarily chose n minus 2 because it was one smaller than the smallest one that I had. I could have taken it back just as far, because it's infinite. I just arbitrarily chose a smaller than that one. Okay? But again, that's just in abstract. You don't have to do it that way. Yes? In the formal way, you should, yes, take it back at least one from the smallest factorial, but I'm not going to require you to ever do it the formal way. I'm just teaching it to you this way because I think it really makes sense how things cross out. But you don't have to do it the formal way. I'm going to do the work in the formal way, but you can adjust as you will. So let's look at the 2n factorials. What would that look like? We would still start out with a 1 times 2 times 3 dot, dot, dot. Again, I'm expanding this formally. Let's see. I actually went all the way back to 2n minus 1. Again, that was arbitrary. Actually, I went back to 2n minus 1. And then that would give us 2n here. Okay. So in the denominator, I have 1 times 2 times 3 dot dot dot. And we're going to go all the way back to 2n minus 1, of course, so they will cancel. And then 2n, and then 2n plus 1, and then 2n plus 2. Okay, so now we cancel, and we're left with 1 over 2n plus 1 and 2n plus 2. Those of you that love to FOIL and multiply, no need to. Please don't. Just leave it like that. Yeah, I mean, if you really must, I guess you can multiply it out if you want to, but there's no reason to. We can just leave it exactly like that. Okay? So all of that is in preparation for being able to simplify factorials when we're doing the ratio test. Okay? We okay so far? All right, so let's work on the ratio test. Again, I'm not going to have you memorize it. I'll write it up for you. So we're basically going to do a limit. Just need a little bit of room here. So the test is the limit as n goes to infinity of, and what we do is the n plus 1 term is on top. So I'm going to take this series right here, and everywhere there's an n, I'm going to put a plus 1. So I have 2 to the n plus 1 over n plus 1 factorial. Okay, that's the numerator of my fraction. That's the formula says. In the denominator, it's just the regular a sub n term. So we're going off this right here, right on the first page, this formula. I'll just write it up here. So the limit as n goes to infinity of a sub n plus 1 over a sub n, the absolute value of that. Okay, we're plugging into that formula. That's a ratio test formula. So the a sub n term is 2n over n factorial. And this is absolute valued. All I have done at this point is just plugged into the formula. Are we okay so far? Okay, just plugged in the formula. So I look to see, do I really need the absolute value bars? Is there anything in there that's going to be negative as n goes to infinity? No, right? There's not. So I don't really need the absolute value bars. I'm going to drop them. I'm not going to continue to use them. And I'm going to rewrite this as a product instead of a quotient. So the limit as n goes to infinity of 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Okay, so I just rewrote the fraction as a product. Are we okay with that? Okay, what I'm going to do now is I'm going to work on simplifying it, and I'm going to take you through every single step. You do not have to show all of these steps. I'm just going to show all the steps to make sure we understand what's happening. So I have the limit as n goes to infinity. This 2 to the n plus 1, I'm going to break that apart to 2 to the n times 2 to the first. Let me explain why I can do that. We know that when bases are the same, we add the exponents, right? So that's what the result of this would have been, is 2 to the n plus 1. Okay, so everybody okay with that? It's just going backwards from our exponent rule, that's all. And you may have already done this before. We're going backwards. So that's times n factorial. Well, so which one is the bigger one, n or n plus 1 factorial? N factorial, n plus 1 factorial? N plus 1 factorial. So I'm going to leave the smaller one alone. And I'm going to take the bigger one and I'm going to rewrite it as n plus 1 times n factorial. Is everybody comfortable with that? I just partially expanded it. And again, I'm just showing every single step. You will not have to. 2 to the n. Alright, so let's see what we can cancel out. So let's see, I have 2 to the n's are gone, and the n factorials are gone. Okay, so let's rewrite. So I have the limit as n goes to infinity of, I have 2 over n plus 1 left. Okay, so let's look at this. Let's think about our rules from yesterday. We worked with limits to infinity yesterday. So as the denominator grows without bound, this is going to get larger and larger and larger. What is this limit going to, what is this going to tend to? 0. This is going to tend to 0, and we compare that to 1. That is, we have to write out less than 1. We're doing the test. It's less than 1. Therefore, what is this series going to do? Is this series going to converge or diverge? It's going to converge. The series is going to converge by ratio test. Oh, that's our very first ratio test. So fun. Are we okay? Okay, let's just do one more. We'll practice one more. So again, let's set up the ratio. And you can see why they call it a ratio test, right? We're setting up a fraction. It's a ratio. So we've got the limit as n goes to infinity of. So we got the plus 1. So we're doing the plus 1 on top, n plus 1. So n plus 1 over 3 to the n plus 1 all over just the regular nth term, which is n plus 1 factorial over 3 to the n, and it's absolute valued. Okay, we have to write it like that, with absolute value. So then we have to ask ourselves, do we need the absolute value for this particular series? Is there anything that's going to be negative? No. No, we don't need it. So we can drop the absolute value. So the next step, I'm going to write it as, just like I did here, I'm going to write it as a product. So the limit as n goes to infinity of n plus 2 factorial over 3 to the n plus 1 times 3 to the n over n plus 1 factorial. Okay, so I'm just writing it as a product. The next step, I'm just for y'all, I'm just going to continue to expand out and simplify. I'm going to write down all the steps. Again, in your own work, you don't have to write all these steps, but I want to make sure we're clear. So n goes to infinity. So which of these factorials is the smaller one? The one on the bottom one, right? This one is the bigger one, so that's the one I'm going to expand. So this one is going to be n plus 2 times n plus 1 factorial times 3 to the n over. So this, if you recall, I'm going to go backwards with that. That's going to be 3 to the n times 3 to the 1. And then I have my n plus 1 factorial. Okay, is everybody okay? Alright, so let's see what we can cancel. Let's see, the 3 to the n's are going away, and the n plus 1 factorials are going away. Alright, so let's see what we have left. So the limit as n goes to infinity of, let's see, we've got an n plus 2 over 3. That's what we have left. So as n grows without bound, what is going to happen to this quantity? It's going to go to infinity. So I'm going to use an arrow. It's going to go to infinity. And I'm going to compare that, just like I did, to 1. Okay, so I know this is crazy. Is infinity bigger or smaller than 1? It is definitely bigger, right? So it's bigger than 1. So therefore, what can we say? Diverges. It diverges by ratio test. Isn't that so fun? All right. Yes. Are we doing okay? All right.